Hi, thanks for tuning in this week. Today we're taking a slight detour from engineering into regulation. And this is about how Europe is rewriting the packaging laws and what the new packaging rules really mean. Because packaging design in Europe is no longer driven by only materials and machines. It's increasingly driven by legislation. And the biggest piece of legislation on the horizon is the EU Packaging and Packaging Waste Regulation, commonly known as the PPWR. This regulation will influence almost every packaged product sold in Europe, including coffee capsules. And if you design coffee capsules, PPWR will shape what you build for the next decade. So please take a second to subscribe, like, and share. The PPWR is Europe's attempt to standardize packaging rules across all EU member states. Historically, packaging requirements differed from country to country, and different recycling systems had different rules, different labeling requirements, different material rules. The PPWR replaces this patchwork with a single framework. For packaging engineers, that means regulation becomes a design constraint, just like pressure or temperature and shelf life. Here's one of the most important changes for our industry. Coffee capsules are explicitly classified as packaging. That sounds obvious, but for years there was a debate. Were capsules packaging, part of the product, or a machine component? Under the PPWR, it is clear the capsules are packaging. And that single classification forces design changes, because once something is packaging, it must comply with the packaging law, including recyclability requirements, labeling rules, waste reduction targets, and environmental performance criteria. So capsule design is no longer driven only by brewing performance. It is now being shaped directly by packaging regulation. So what are the goals of the PPWR? At a high level, PPWR aims to reduce packaging waste and improve recycling. The main goals include reduce overall packaging, more recyclable packaging, a higher recycled content, better collection systems, clearer standardized labeling. The goals sound straightforward, but implementing them is not. One of the biggest shifts under the PPWR is recyclability by design. Packaging must increasingly be designed so that it can be recycled in real systems, not theoretically recyclable, actually recyclable. This means fewer mixed materials, fewer laminates, simpler structures, clearer material identification. This is a fundamental shift, and that's where the tension begins, because many of the best packaging structures for product protection are a multi-layer. You may ask yourself, why is this a big deal for coffee capsules? Because coffee capsules sit right at the center of this challenge. Capsules must protect aroma, control oxygen, manage moisture, withstand pressure, and interact with the machines. All of this normally pushes designers towards complexity. And the PPWR pushes the limits now even further. So capsule packaging engineers now have to balance performance versus recyclability, and neither one can be ignored. One of the strongest signals coming from the PPWR is the move towards mono-material packaging, because mono-material systems are easier to sort and recycle. Examples include aluminium-only packaging, polypropylene-only packaging, and fiber-based packaging. Monomaterial packaging reduces confusion and improves recovery rates. This is one reason we're going to be seeing recyclable PP capsules, aluminium collection programs, monomaterial pouches, and less tolerance for mixed structures that can't be separated. The regulation is pushing packaging towards simpler material systems. Here's a big confusion: recycled content versus food grade rules. Now, this is where things get a little messy. On the one side, the packaging world is pushing for more post-consumer recycled content, or PCR. That sounds good, but coffee capsules are not just packaging. They are food contact packaging, and food contact is governed by a different set of rules, food safety regulation. So you can't just take post-consumer waste, melt it down, and put it into food-grade packaging without strict controls, authorizations, and compliance requirements. So we have a little bit of a disconnect. Packaging policy pushes increase the PCR content. Food safety pushes must be extremely careful with PCR and food contact. And the industry and the capsule industry has to live in that gap. This isn't ideology, it's a practical engineering and regulatory collision. So, if the market is being pushed towards recycled content, but mechanical recycled feedstock is limited in food grade application, what's left? In practice, the main pathway being discussed today is chemical recycling. Chemical recycling breaks plastic down into molecular building blocks, allowing production of virgin or equivalent grade virgin polymers that can be suitable for food contact application. On paper, this sounds like the perfect answer, but it introduces two new problems. The two new problems are the reality, feedstock and cost. The problem number one is there is not enough feedstock. There simply isn't enough feedstock available today to supply the whole market. Chemical recycling needs consistent input streams, controlled polymer types, stable volumes, and right now those streams are limited. And as more industries chase recycled content targets, they will all compete for the same feedstock. So even if the technology works, the supply isn't there yet. Then there's problem number two, the cost. Chemically recycled feedstock is significantly more expensive than virgin polymers. Not a small difference, a meaningful one. And when you multiply that by billions of units, cost becomes a structural constraint. So yes, chemical recycling can help solve compliance questions, but it creates pressure on economics and supply. Now let's talk about trade-offs, because regulations always come with trade-offs. Simpler materials can mean weaker barriers, shorter shelf life, heavier packaging, or increased food waste. And food waste often has a much larger environmental footprint than the packaging itself. So there is a real risk of solving one problem while creating another. Engineering is about a balance. Regulation sometimes forgets that. So talking about balance, to be fair, the PPWR gets several important things right. It pushes the industry towards honest recyclability, better collection systems, reduced over-packaging, and clearer labeling. And it forces companies to think about end of life, not just manufacturing. That's a positive shift. What the PPWR gets wrong. Where the PPWR becomes difficult is when theory meets reality. Recycling infrastructure differs between countries. Materials behave differently in real systems. Consumers don't always follow instructions, and sometimes regulation assumes ideal conditions that don't exist. The gap between policy and practice is where the engineers spend most of their time. 10 years ago, packaging engineers mostly worried about materials, machines, performance. Today, we also need to understand legislation, recyclability criteria, recycled content rules, and what claims you can legally make, because the best design in the world is useless if it can't be sold legally. So in closing for this week, the PPWR will reshape packaging in Europe. And now that coffee capsules are officially designated as packaging, the impact on our industry will be significant. Capsule design will no longer be driven only by brewing performance. It'll be driven by actual performance, sustainability, and regulation all at once. Packaging design in Europe is no longer just engineering. It's engineering inside a legal framework, where sometimes the rules don't perfectly agree with each other. This has been Engineered Coffee. Please, and as usual, please like and subscribe and share, and I'll see you next